For those that have just joined and are in the process of joining, please bear with us. We've got potentially 1,000 people joining this webinar. So just a couple more minutes, please, while everybody's joining. Right. Good afternoon, everybody, and welcome to the Passivhaus Trust and from the Passivhaus Trust team. Some of you are going to be joining us. We've got quite a lot of people signed up today. We're currently on 275 and the numbers are creeping up. So I'm going to start my introduction now. If you've attended one of our in-person or online events before, then we hope you'll learn something new or gain further insight and enhance your Passivhaus experience. If you're new to the Passivhaus Trust, then a warm welcome, and I hope the next 2 hours will give you some useful information and be enlightening. Today's session is part of the Passivhaus social campaign and is third in our four webinars this year. So we're going to take a deeper dive today into costs. Previous sessions can be viewed, and today's will be available in one of our electronic party bags that you'll get afterwards, with a link to the recording and some other useful guidance and information. So today we have 5 very experienced and knowledgeable people who have all delivered Passivhaus projects and can offer a great insight into the fascinating world of cost. So cost, as you can imagine, or may have experienced, is multifaceted. So there'll be many dimensions today presented by our 5 speakers. So again, just to reiterate, there's a huge number of you online, over 300 so far. So the structure of the session is, after each pair of speakers, there'll be a very brief, quick question opportunity for any posted in the Q&A section. And then there'll be a much wider discussion at the end. So please post questions in the question and answer function rather than the chat. We will try and keep a look, and just in case that any have been misposted, but question and answer is where we'll be looking at. Q&A section you'll see at the bottom, and please try to upvote any that are similar to what you would like to ask or that you like the look of. That will be the quickest way we can get to questions. I think I just saw a hand pop up there, but I think it might have gone. So hopefully that's answered it. We will unlikely to be covering every single question that gets asked just because of the sheer number of you. But please, we will try to cater as many as possible. And we will try to finish promptly at 4 o'clock today. But again, given the numbers, we might overrun slightly. So if you have to leave dead on 4, please do so. And please do use the chat just to say hello, as a number of you have, so that's nice. Okay, before we start with our first speaker, a very quick poll, if we may, just to sort of gauge where everybody's from in terms of their sectors. So Lynn, if you wouldn't mind putting the quote, yeah, we go, there's the poll. If you could very quickly, that's great. Look at that. Just gives all of our speakers a better understanding of the audience today. where everybody's drawn from and their particular interests. So we'll just give it another few minutes. I think, Lynn, we can probably leave the poll open and then make a start with our first speaker. So I'd like to introduce Sarah Lewis, who's the Passivhaus Trust Director for Research and Policy. And over to you, Sarah.
Thanks so much, Paul. I'm just going to share my screen. Share. Okay. I've only got 15 minutes today and I've got quite a lot to get through. So I'm going to rattle a bit through the slides, but hopefully everything gets across, and obviously there will be an opportunity to ask questions at the end. So I'm going to talk about evidence-based social housing costs today. So the Passivhaus Trust has been developing kind of cost and benefit research over the last few years just to support the case for Passivhaus in the UK. We launched our cost papers shown on the screen here in October 2019, and then our benefits guide was launched at the UK Passivhaus conference in 2021. So I'm going to start the presentation today by kind of summarizing some of the key takeaway messages from that cost paper, but costs are a broad subject. So I will also be referencing from our benefits paper as well. And then I'm going to close the presentation with a bit of a call to action and some next steps for us at the Trust. So firstly, the cost paper. There's a QR code up on the screen, and I recommend that you do go and have a read through the detail of this paper after the session today, as much of the paper is still as relevant today as it was in 2019. The original presentation slides as well from 2019 are also available on our conference website, and that paper or that presentation goes into more detail on the paper, more than I have time to go into it today. The study itself looked at several kind of historical Passivhaus developments to derive the cost premium, or the sort of extra cost of building to the Passivhaus standard. And it compared these results with previous analysis and other reports to demonstrate the cost trend and where it's likely to settle should Passivhaus be adopted at scale in the UK. And while in 2019, that kind of at-scale adoption of Passivhaus might have seemed overly optimistic as a future projection, we do now find ourselves living in that future, or very nearly so anyway, with the Scottish Passivhaus equivalent standards being laid at the end of next year. So Passivhaus adoption at scale is now very much on the doorstep. So the overall summary of this trend, as it's set out in the paper, is shown here in this chart and demonstrates that back in 2018, the best practice was delivering Passivhaus at around an 8% extra cost. And that future projection I just talked about for at scale was set at 4%. So the study itself examined a range of different Passivhaus residential developments, which were all completed between kind of 2014 and 2018. And that was to determine those extra over costs when compared to a non-Passivhaus equivalent. So it took those Passivhaus buildings and then looked at the equivalent. The majority of these developments were built for social landlords and or for modest size. So we were looking at kind of 3 to 90 units. And they comprised, as you can see on the screen here, of a range of typologies and tenures. Construction methods also varied from things like timber frame, which might have been faced with brick or render, to masonry cavity walls, some solid masonry. The insulation in these buildings also varied. So we had insulated timber frames, we had insulation which was integral to masonry, we had cavity insulation, also external insulation, and sometimes a combination of these on one project. For information, from the information that we were able to take from these projects, it was possible to arrive at those indicative costs per square meter for that additional cost of Passivhaus. And that was broken down into a variety of elements or stages of construction, the construction process to which those applied. And then from this, we arrived at these potential range of extra costs per meter squared. And as you'll see on this slide, we broke that down so we can see where those extra costs sat. So this is from back in 2019, and we would like to now revisit this analysis, and that is something we're going to be doing for 2024. And I'll mention more about that at the end of the presentation. But this is looking at, it's very clear from this graph here that the biggest extra cost, hopefully you can see my mouse here, is coming in with the MVHR. And we are seeing MVHR as a much more standard specification coming into a lot more properties, not just passive house buildings. So maybe the extra cost of that is less. You can also see that in the passive house buildings, we're actually seeing a lower cost for heating and hot water due to the smaller size and more efficient design of those systems. And then one other thing I thought is just worth mentioning is we did as an extra cost, that quality assurance. So we included that in our analysis, but it is something I would put to you today. Should this really be seen as an extra? Is the current kind of business as usual approach, which is delivering typically a 60% performance gap, acceptable? Shouldn't we expect our building teams to be delivering the performance which the clients are asking for in their specifications? So that's kind of an open question. So Exeter City Council were one of the local authorities who contributed to this cost paper. And with nearly 9 years of experience back in 2018, they were confidently building passive house at that premium of just 8% over the baseline. And we're confident with that kind of steady state projection of passive house adoption at scale being achievable at that sort of 4% uplift. And in fact, Emma Osmondson, who was at Exeter City Council at that point, was just quoted in July this year in Inside Housing saying, we've been able to demonstrate you can virtually eradicate the cost of building to passive house. And she said that a low-rise block of flats in Exeter was actually coming in 4% cheaper than building regulation compliant equivalents. It's a great article, so go and check that out. I put a link up on the screen. I realize I should have given it to the team beforehand so they could put it in the chat, but we'll get it in the chat after I finish the presentation. And I think, of course, we shouldn't ever really be talking about capital costs completely in isolation without thinking about the impact of energy bills. And of course, this has been a much more important topic in the years since the completion of that paper. The data here is from the time of that paper, so 2019, 2020. And I was just interested to see what the difference would have been to today's figures. So I just reran the calculation yesterday. So it's updated to yesterday, the cost of energy. And you can see the first two are the kind of building regulation compliant buildings, ones with gas and ones with an air source heat pump, assuming an efficiency of 2.6 on the COP. So you can see that the cost increase on that kind of building regulation building was over £700 compared with the passive house building, which had an increase of less than £500. And that's really significant for our building occupiers. And I did share these slides in the introduction to this series back in January, but I'm going to reshare them now because it's really relevant. And I think we've got a lot of people joining today who haven't necessarily seen these. So a passive house will significantly have a lower heating bill. So off those bills, that was total bills we were seeing on the last slide. Now I'm zooming in and just looking at heating. Heating is the lion's share of the energy costs in a typical new build house. But in a passive house, it's actually been reduced so much that it's 83% cheaper to run a passive house than a new build building regulation compliant building. Now, this has absolutely huge implications on health and well-being of residents, as when energy costs go up, if the heating is the biggest chunk of your energy bills, that's where you're going to be turning off the heating to be able to afford your bills. So this graph is showing those costs in 2021. And we updated those in 2022, and you can see those higher numbers now. And that represented an extra £128 in the building regs compared to an extra £23. So keeping the heat on in a passive house when we do have these energy cost spikes is much more achievable. And then, of course, what's next? We don't know when the next energy cost crisis is going to hit. We don't know how high energy bills can go. That's anyone's guess. The figures shown on this slide are based on the costs that had been projected for January this year. Although with the caps and then the stabilization of costs, I don't think we actually quite got here. But it's interesting to know this is what we were kind of preparing for. And you can see there a really significant increase on that building regulation home compared to the passive house. So keeping heat on in a passive house, which is imperative for occupant health and well-being and building health as well, is much more doable in a passive house. So to achieve this, there are several kind of key success factors which set a passive house development apart from a typical project. And these are summarized in that cost paper, but I'm just going to run through them quickly here. So passive house absolutely needs to be part of the original brief if you want to make a passive house affordable. You should really have an experienced team of consultants working on the project, and you want to keep it simple. And by that, I mean you can make simple early stage kind of design decisions, focusing on things like good form factor, good orientation, simple detailing. These are all really effective ways to keep costs down. Ventilation is, of course, absolutely critical to the design and needs to be thought about early. Summer comfort, especially, and sort of future resilience is really important in our buildings. And that's all kind of part of the passive house package and calculation. Air tightness, we know that's really key, and that will inform things like how we're going to procure the building potentially, certainly how we're going to construct it. You want to be working with a team who get it, who are bought into delivering buildings that perform. And then you want to make sure you have an ability for you to have a good collaboration between the design team and the contractor team. And finally, you want to be appointing a passive house certifier to your project. And you want to do that pretty early, usually around the end of stage REBA stage 2, maybe start of REBA stage 3. And if you're unsure about the kind of consultants you need on a project or the different stages at which you need to do things on your project, do download the REBA Plan of Work overlay for Passive House. It's a really good document. We collaborated with that with REBA. It was authored with Mark Siddle, one of our members. So it's a really excellent document, and I definitely recommend you have a read of that. I'm sure the team will be popping it in the chat. Okay, so I just wanted to put this slide up. We're just past halfway through the presentation, and this is a kind of hark back to a presentation which was part of the intro session. So Joel Callow presented this passive house versus nearly passive house session on the 18th of January. And he started with this great prompt. He said something along the lines of, let's imagine a building that's somehow cheaper than a passive house, skips on certification because that's a bit expensive, just about puts all the right targets in the ERs. Is this good enough to deliver what the clients want? And I would expand that to say, is just having an aspiration alone enough to translate into the delivery of performance? And unfortunately, what we see is if it's not passive house, we typically find that nobody is really checking, verifying the design at an early stage, the construction throughout, to a sufficient quality to have that kind of golden thread of quality running through the project. And it's that golden thread of quality that leads to the delivery of performance and health for both the occupants, but also the buildings. So that's just something I think it's worth highlighting. And do go back and watch Joel's presentation if you missed it. And then all of this leads nicely to our benefits guide, which was published at the end of 2021. QR code, again, is up there on the screen. And that research identified almost 50 types of benefits relating to passive house, which have been categorized into these kind of 6 distinct areas. So building performance, climate emergency, health and well-being, people performance, financial and social. And when taken together, they really do make a compelling case for the adoption of passive house. Each of these 6 chapters is then backed up by really detailed research papers, which have been produced by the Passive House Trust in collaboration with Kate de Selencourt, who I think might even be on the call today. So she might be able to answer your questions on health and well-being in the chat. And they are the first of those papers is already available to download from the Passive House Trust website. Again, go to that QR code. It's the one on health and well-being, and it is an absolute treasure trove of information that Kate's pulled together, and it's available now. So do download that. I'm looking at the time and thinking I'm probably going to run about 3 minutes over, but Alan told me I was allowed to, so I'm going to carry on, but I'm going to keep up the pace. So apologize if it seems like I'm going a bit quick. So there are many financial benefits for passive house projects, and actually EnerFit, which is the retrofit standard too. And these benefits are very far ranging and actually make up the largest chapter in that benefits guide. I don't have time to go into it in detail, but what I'm going to do is I'm going to rattle through some key takeaways in terms of financial benefits. So you get those lower energy bills we talked about. In rental properties, there are fewer and shorter void periods. It reduces the extent and depth of fuel poverty. You can actually get higher capital value of between 5 and 7%. So that could automatically offset that 4% construction uplift. Lower maintenance costs, lower management costs, ability to access cheaper time of day tariffs, really important for our occupants. Lower whole life costs, I've got a graph on that in a second, lower borrowing costs and green mortgages, access to cheaper green finance. And also these assets, these buildings are going to hold their value in the event of future climate, carbon or efficiency legislation that the government brings in. You've got lower risks of a defect litigation and lower risk of repetitive damage. So loads of financial reasons to make this decision as well. And thinking about the kind of wider cost to the country and the nation and the whole issues around the climate emergency, there's always going to be a finite amount of renewable energy. And at the moment, our grid can't deliver the peak power needed to heat all our homes and provide all the hot water unless we really do slash the demand. And we also need to have demand flexibility. Now, Passivhaus helps with both of those limitations. And as shown on this slide here, it's actually cheaper to save a kilowatt than it is to generate that kilowatt. So this is just showing that the Passivhaus, the small extra cost for Passivhaus over building regs is going to be cheaper than generating new renewable energy. So also it's just something for us to think at when we're looking at that big scale. So to deliver all of this and effectively eliminate the performance gap, the Passivhaus standard requires this really close attention to kind of focus on site, which results in the final building being of a superior construction quality than one that didn't have this kind of focus and level of supervision and attention to detail. And then to achieve the required levels of thermal performance and air tightness, the individual components tend to be of a higher quality. Now, as we just discussed, there is a slight cost associated with that, but then these components tend to last longer and require fewer callbacks during use. So that not only improves the occupant experience, but also has a significant benefit for developers and landlords. And then having that robust air tightness layer, it doesn't just help us from an energy point of view, it protects the fabric of the building from condensation getting in there. And therefore, we're reducing the risk of unseen mold and rot. And then finally, we've talked about just very briefly there, we do live in a warming climate, and the thermal stability of a Passivhaus really provides resilience in the face of temperature extremes. And this is Alex Rowley, who was the MSP up in Scotland, who put forward the bill for all new homes to meet the Passivhaus equivalent standard. And he said, building a Passivhaus is the epitome of a spend-save approach. By investing now, we save both financially and environmentally over the term of the project. And I think that's a really important sentiment. The cost to the nation of fuel poverty and poorer performing homes has to include things like the cost to the NHS, as well as the cost of needing to upgrade that energy grid. And we don't often factor these things into our calculations. And in fact, in 2023, BRE brought out a new cost of poor housing report in which it estimated that the NHS has to spend £540 million a year in England alone to treat people affected by poor housing. So this is that through life cost diagram I said I would share. And this is just to say that, as you can see, this is looking at different types of sort of heating systems in the building and the different payback periods. But it can pay back in as little as 7 years, depending on that choice of energy system. And this graph was based on the 2020 figures. So if we actually think about today's higher cost of energy, you could easily knock a couple of years off these as well. And I think in all these discussions that we're going to have around cost today, it's really important to not forget the huge and measurable impact that how our building performance affects people's lives. This is a quote from a resident in a project for Broadland District Council down in Norwich. We all now have amazingly wonderful sleeps at night, which we believe is due to the air quality. The consistent temperature of this house is perfect. So just to summarize, in the context of other factors, such as things like the higher quality or higher performing building products or decisions around building form, or maybe the ground conditions on site, those things can all result in that kind of higher build cost. So the extra cost of the Passivhaus upgrade becomes a sort of minor uplift. And that 4% uplift does result in a much superior project in terms of running costs, carbon emissions, comfort levels, and health benefits. So this is my final slide, a bit of a call to action. So we need you. Loads of people have joined today. There's clearly a lot of interest within the housing severe for people delivering Passive House. So we want to create a new cost research working group for 2024. So if you want to be part of that, do get in touch. We want you to share your project costs. You can do so confidentially. We want you to also share your learning, share your best practice stories, share your challenges, because that will all allow us all to learn and move this forward as a nation. And I've put my email address at the Passive House Trust up on the screen. If you do want to get involved in this work, please do email me directly. And on that note, I am going to stop the presentation. I'll hand back to Alan.
Actually, hand it back to me quickly. Thank you, Sarah. Yes, very, very complex, multidimensional, but really getting into the sort of depth of all of the bits that we know, some of us certainly know, regarding costs. And it's not just about direct costs, it's about indirect costs and longer term costs. And I know a lot of the other speakers are going to be touching on some of these, but without further ado, thanks again, Sarah, and over to Alan Watkins from Calm Consultancy Services, who's going to speak a little bit more about the Passive House fundamentals, performance and better value. Alan.
Thank you, Paul. Yeah, I'm going to pick up on a few of the things that Sarah mentioned there, particularly from a social housing client perspective. Really looking at the Passive House fundamentals, what they are and how we go through the right process in design and build to actually make sure we're getting the best value. So as Sarah mentioned, Passive House buildings can look very different. They can be built of many different materials, could be timber frame, could be masonry. There are different approaches, but yeah, effectively it's any kind of way you want to build can be built to a Passive House. But what they all do have in common is real emphasis on building physics, very fundamental to the design, and have to make sure that that's carried through the build process. What I'd like to expand upon is how really focusing on building physics actually sits very well with value engineering. Now, it's a phrase that we hear a lot, just to clarify that it's not cost cutting to rescue a budget. That's where it's often used, that phrase. But no, it's not. It's not rescuing a project once it's already too expensive. If we look at this diagram and we add in the REBA overlay, which again Sarah mentioned, see the REBA stages there. So we can see we're moving through time through the sort of design and build process. And on the we have the two curves there from the top left. Curving downwards is the value curve, and from the bottom left, curving upwards is the cost curve. So that the earlier we make any design and decisions, the more savings are possible, and the less it costs. So as we move through time, the costs of making changes grow, and the value of those potential changes actually decreases. In terms of the standard approach to design, the sort of work is usually done around sort of REBA stage 3, stage 4 in terms of the detailed design. But with both building physics, Passive House approach, and the value engineering approach, we're really looking to front load things so that we're getting a lot more design work in up front and making decisions that are really taking advantage of a lot of those savings, a lot of those free gains. So what are we talking about there? How do we do that? Key is right up front at the sort of strategic stage where we're really deciding feasibility and what we're actually going to do. We really need to start thinking about energy then. Achieving net zero is obviously now a target for social housing. It's the only game in town to a large extent. And energy performance is often now a key funding requirement as well. So really it's a key determinant of value. When we talk about value, we're often talking about energy efficiency and many other things that Sarah touched on there, such as easy low maintenance and longevity of components, that kind of thing. So when we're looking at potential development sites, we really need to start looking at the feasibility with energy in mind. The later through the process that we actually start thinking about it, the more it's going to cost us, and potentially the less gains will be achievable. We need to target low energy demand, not generation. This is not about throwing photovoltaics at buildings. Typically, the roofs aren't big enough to actually make a meaningful dent in their energy demand. We have to think about lowering that energy demand, particularly with regards to space heating, right from the outset. So we need to work with physics rather than against it. So there's a few, few fundamental sort of physics concepts that we don't need to understand in detail, just to be aware of as from the client side in terms of how we approach schemes. So fairly early on, here we're looking at still very early stages, but when we're looking to sort of brief a consultant team, and we're still looking at feasibility very much so. We need to really put together a site-specific energy model. So it might be very similar buildings that have been used before, might be adapting things on a sort of pattern book or that kind of thing, but you still need to actually apply it to the site that you're looking at. The best tool for this is the Passivhaus planning package, PHPP, which is great not only for the building physics that is its sort of principal reason for existing, but from a value engineering perspective as well. It's very cost effective, very cheap, costs less than £200. It's very familiar as well in terms of the Excel basis that it is basically a very large Excel spreadsheet workbook. So there's not, people don't have to actually, everyone knows how to use Excel pretty much, so you don't have to learn how to use the software. You can focus very much on what it's actually dealing with in terms of the building physics. It's a design tool. It's not just for compliance with the Passivhaus standard or with standards such as the AECB, which use the same kind of design tools. It is an overall design tool, so it can actually inform architectural designs from a very early stage. This stage is Design PH, which actually allows 3D designs in SketchUp to be very, very easily and quickly converted into PHPP, so you can actually see very quickly the effect of any design changes on the building energy performance. Into this moment, but yeah, we're really talking about the physics metrics. So the key one being space heating demand, looking at kilowatt hours per meter squared per annum, rather than some kind of extrapolated concept such as EPCA or anything like that, which is a little bit impenetrable sometimes. It's a bit of confusion about what that might mean. EPC rating SAP changes periodically, but a kilowatt hour is always a kilowatt hour. So we're very much focusing on those physics metrics in our energy model, and it's very I would say easy, but it's quite quick then to convert this to a concept stage cost plan, and see what the budget's looking like from the outset. Embodied carbon can also be quantified at this stage. You're getting the quantities in early, and you can start to make those tweaks, which can potentially quantify embodied carbon. Again, as with monetary value, it's best to look at embodied carbon early on. It's much easier to make changes and they cost less. So the earlier you start thinking about that, the better. So really what we're looking at is targeting the three gains. We're looking for a sweet spot in terms of getting the energy balance right. So that's heat losses and heat gains. So how do we do that? Again, some of the fundamental physics approaches that Sarah alluded to. Here we're sort of moving perhaps into sort of concept design. Optimizing the form factor is very important. It's effectively looking at the ratio between the external surface area, the heat loss areas, so the floor, the walls, the roof, windows and doors, so the external envelope compared to the internal volume and the internal floor area. So it might be a little bit small to see the numbers there, depending on the size of your screen, but the top left-hand building there is got a heat loss form factor of 3.73, the single-story one there. It's one next door, which has got exactly the same footprint, has a heat loss form factor of 1.96, which is much better. The lower the form factor, the better. And if you can get below 3, that is where you need it to be headed. The only one of those there which is above 3 is that single-story one there on the top left, which is 3.73. The rest are all below 3, and some of them are below 2. So it's well worth doing at a very early stage, making sure your form factor is as efficient as possible, but you haven't got kind of sticking out bits here and there which just enlarge the the envelope that you've got to heat. Worth bearing as well that a lot of the cost is in the thermal envelope. That's where all the insulation needs to be. It's where your air tightness layer needs to be. So the smaller that can be in relation to the internal area, the cheaper it is. And it's worth bearing in mind as well that the value of a building is actually in its internal area. Certainly commercial buildings are kind of leased on a square footage rate. And similarly with housing, you know, need minimum space standards, that kind of thing. So it's being able to achieve those with the smallest possible heat loss area. So if we get this right early on, it makes everything subsequently look a lot better in terms of the pounds and the pence. Similarly, orientation, same sort of stage in the design process. Definitely worth looking at the two together. In terms of optimizing orientation, we're really looking at the sun. So we're looking at the sun path. It's passage through the sky at different times of the year. It doesn't mean that we have to have a lot of south-facing glass. It can do, but it really comes down to measuring it. What we're looking to do is balance heat loss and solar gains. We're really looking for about 30% of our annual heat demand to be supplied via solar gains through the windows. If we go much more than that, which is easy to do with lots of south-facing glass, then we're getting into sort of territory where we're going to have it overheating risks. So 30% is usually about the right level. Now, sorry, my camera's gone a bit funny, I think, but hopefully you can still hear me, if not actually see me properly. Yeah, so what we do need to do is model the impact of those of the orientation and consider the layout internally to suit, just to make sure that balance is about where we want it to be. It's much easier to get 30% of your annual heat supply with good high performance fabric, good insulation, good windows. You wouldn't do it with most buildings, but with a good fabric you can. So we need to look at orientation as well as form factor together. And the other significant factor here is glazing, same sort of time. And again, looking at orientation and glazing proportions, they're really pretty inextricably linked, because it's the windows that is where we get both the heat losses from solar gain, sorry, other way around, heat gains from solar gain and heat losses through the transfer of heat. So what we can see here is the difference between the winter sun and summer sun. So winter sun is much lower in the sky, and that's when we want to get the solar gains, whereas the summer sun is much higher. You can see there the overhang of the roof is actually stopping the sunlight directly hitting the glass. So yeah, that's the kind of thing we can actually model in PHPP. We can change the size of our windows. We can, on different elevations, that kind of thing. We can put shading in, add it and take it away to get that balance about right. So we're really looking at optimizing size, shape, and also the specification of things like the glazing units, the sort of G values and that kind of thing, to get a little bit technical with the actual glazing units. So yeah, again, we're looking at balancing the heat gains versus losses. Doesn't mean they have to be south-facing. It just means it has to all be taken into account. Shading calculations are included as well. It's worth bearing in mind that windows and external doors are a high capital cost item. So lots that can be done in terms of the pounds and the pence, in terms of getting that right by tweaking the specification on the windows. Non-opening windows are cheaper than opening windows. So you can maybe play around with that. Obviously, a slight myth that does perpetuate is that you can't have opening windows in a passive house. That's not true. You can, but in certain instances, you might want to save some money by having certain windows non-opening. And yeah, just playing around with the size and shape can do a lot in terms of pounds and pence, particularly if you've already identified a manufacturer that you might want to use as a start of 10 in terms of your cost planning. So even if you that's where all the sort of free gains are. If you do nothing else, then it's definitely worth doing that with a development site, looking at optimizing all of those factors before you go any further. You get into the nitty-gritty of the construction detailing. So here, there's some fundamentals to follow. Now, the demands in this area, just for all buildings generally, are getting higher. We're looking at higher values of higher insulation levels and better air tightness. So the key principles here are you need a continuous insulation layer, and that's for minimizing, if not completely eliminating, thermal bridges, reducing heat losses, and also mold risk. Sometimes people sort of imagine that if you've got a building 90% insulated, then you've only got 10% sort of heat losses through the bit that's uninsulated. Actually, you're getting more, you get higher heat losses through those areas, and that's what leads to cold spots and therefore condensation risk and mold risk on the inside. So yeah, very important to have continuous insulation layer, minimizing penetrations. If you can do away with things such as penetration through the roof for soil and vent pipes, if you can just keep that, use Durgo valves, etc., or even just have less stacks to minimize penetrations, then that just makes it all perform better. And you need a continuous air tightness layer as well. If you can see the red dotted line on that detailed diagram there, that is the air tightness layer. Very important in terms of any high performing building, both to be clear about the insulation layer and also where that air tightness barrier is. Just going back to windows quickly, they are part of the insulation layer. They're not a very high performing part of the insulation layer. They're the weakest part of the insulation layer, but they do form part of that layer, and also the air tightness layer. So that's another reason why there's such an important element of working with building physics and value engineering, because they do such an important job there as well. Quick word about build systems. As Sarah said, construction method agnostic in terms of Passivhaus, AECB, any kind of high performance buildings. Doesn't really matter whether you're going timber frame or masonry build, for example, it can be done. However, it is often better to work with tried and tested systems rather than individual components. It just makes life a little bit easier. MVHR is required, and this is actually where the conversation about offsite manufacture and MMC comes in. It definitely has a significant role. It can help make things a lot easier, but I think it's important to be clear about what are you trying to achieve with offsite manufacture. Sometimes it seems a bit of a panacea for every problem in the building industry, but yeah, I think it's good to be clear about what you're trying to achieve. Is it better air tightness? Is it insulation continuity? Is it finish of internal finishes, qualities, that sort of thing? Always good to have early contractor and manufacturer involvement, and have a procurement strategy which supports these aims. So being that we're front loading the design process much more, is design and build actually the best form of contract? I'll leave that out there with a question mark. That's just asking the open-ended question more than actually providing an answer, but something we need to think about, I think. I'm not going to talk too much about occupancy.
Couple more minutes, please, Alan.
Okay, great. I will skip this bit then, because there is actually a handover maintenance and Passivhaus living webinar. It's the last one in this series on the 29th of November. So I'll just skip through this quite quickly. A lot of these we can pick up in the Q&A about staff and residents. I want to move on quickly to case studies. Case study number one: what happens if you don't have a PHPP model and just, as Sarah was saying, just kind of try to build something that looks a little bit like a Passivhaus, but actually isn't certified. There's no PHPP. We had a scheme I've been looking at recently, sort of troubleshooting. It was inspired by Passivhaus, but with no PHPP modeling done. And the specifications were good enough in terms of insulation, air tightness, windows, doors. The spec was good enough to achieve Passivhaus certification. However, the form factor wasn't good enough, particularly on some of the bungalows that were there. There was too much glazing into the form of large patio doors and some Velux windows. And ultimately, the choice of heating strategy was pretty misguided, because PHPP said no, you shouldn't do it, but they tried to actually use heater batteries in the ductwork to heat the buildings. So looking at this, had it been done, well, I actually did a retrospective PHPP on all the buildings, and if you see the top there, that's what it would have been with the Passivhaus standard 15 kilowatt hours per metre square per annum heating demand. Average heating cost would have been £262. However, the form factor and orientation wasn't that good. So just on that basis, it was down to 30 kilowatt hours already, with a uplift in the costs. And then with the heating in the using the supply air and heater batteries, that pushed it right up to 43 kilowatt hours because of the excessive ventilation losses. So that was then putting tenant costs up at nearly £1,200 a year on average. Now, there's some things we can do in terms of remediation. We're looking at moving to direct electric heating. That's about the best we can do with the form factor and the orientation that we have. And yeah, we'll be retrofitting those to get their tenant bills down. We can only get it about £786 on average. So it's better than where they are, but it's nowhere near as good as it could have been had it been modelled properly. And obviously there's a cost per home to remediating those in terms of changing the heating systems over. And also we're going to have to put PV and battery in just to sort of mitigate the increased running costs. So we're looking at at least up at about £15,000 mark per home, plus all the kind of things that are uncosted, such as reputational damage. So final slide, another case study, looking at what happens if you follow the process and have a PHPP model, that kind of thing, but don't actually have the value engineering mindset. This is again social housing, £5 million block of 34 apartments. These were actually Passivhaus certified, the whole block. However, there was brise solaire put over the windows on the west-facing emergency stairs. There was just a fire door leading onto a stairwell from each floor and a fire exit at the bottom, so nothing particularly flash about the stairwell. And on the south elevation, there was another stairwell that was actually shaded by trees and a hill. So it was very much, the brise solaire was almost an architectural statement rather than being necessary. Now, had PHPP, if it had been asked the right questions, would have told you the answers in terms of, yes, you don't need brise solaire if you just do certain things. Openable windows on the stairwells, they weren't needed for mitigating overheating, that kind of thing, because the smoke vents at the top of the stairwells were actually linked to thermostats, so they opened to mitigate overheating. So that was already taken care of. So a proper value engineering approach would have meant you had smaller windows, you didn't need to open, and you wouldn't have had to put the brise solaire at a great cost on the outside. So had the PHPP been interrogated with this kind of question in mind, could have saved £100,000 just on 2 stairwells. One of these brise solaire you couldn't even see. It was tucked around the side of the building, and that was 2% of the capital cost. So just a couple of quick case studies there about the right approach using fundamental physics to get the best value. So thank you very much, and I'll hand back to Paul now.
Thank you very much, Alan. I think given the time and knowing Alan's wealth of experience and expertise, both in delivering and in troubleshooting, I'm going to move straight to the next speaker and then ask Alan if he'll have a quick look at the Q&As, the ones that have been upvoted, to answer some of those in the next Q&A session, but that will bring us back to time. And don't worry, those questions that Alan can give us some insight and will be answered, but I think that will just pull us back in, and then we'll have plenty of time at the end. So I'd now like to welcome Patrick Watson from 3PM, and Mark Lodge from ISG to going to do a little double act. And I think I'm right in saying that Patrick is going to be up first. Thank you, Patrick.
That's right. Thank you, Paul. And good afternoon, everyone. As Paul said, Mark and I are going to do a bit of double act. I work for the client-side project manager, and Mark worked for ISG, who are the contractor for this scheme. We're going to talk about a Enefit refurbishment. It's a commercial office scheme. You can see the strap line on the hoarding there, and very much the aim and the brief we were set with this project was to ensure that we could deliver this scheme within normal benchmarks for a refurbishment. Next slide, please. So just to give you a very brief. End user was spread over three different buildings in the city. They were looking to come together to create a new corporate HQ. CISL is the Cambridge Institute for Sustainability Leadership, and therefore, as a result, their new HQ had to be a living laboratory and demonstrate that they were driving leadership in sustainability. You can see some of the challenges we set out there. So our brief was for BREEAM Outstanding, ENERFIT standard with lower embodied carbon, 50 plus innovations, 70% bio-based materials, full POE, more importantly, replicable and with some very tight risk control. Next slide. We were originally set a fee budget, which was based on a standard Cat B fit out, which obviously proved not to be sufficient for the brief that we were actually given. We were told to use a single stage tender via a framework, which and ISG were on the framework. And our QS at the beginning of the project, who was G&T, were giving us the advice that this brief was going to give us a 25% premium. Just to make it harder, as a project team, we decided to also add Well Gold as a part of the accreditations. This made it a world first, and I'm not aware of any others that have achieved all 3 sets at the moment. And to make it even easier, do it in the middle of a pandemic and post-Brexit. Next slide, thanks. So for those of you who want to know more about the project, there is very comprehensive case study online. You can see the link there. It's a 30-page case study of all of the technical parameters. What Mark and I are just going to talk you through is the actual cost and project management related issues in delivery of this scheme. Thank you. Next slide. Mark. Mark, you there? So whilst Mark's not there, I'll carry on for him. Okay, so you've seen a number of the key risks that Sarah was outlining earlier. This was part of a post-project review we undertook. Okay, Mark, off you go.
My apologies, sorry about that. I was talking. So I did say it's a blessing in disguise that you can't see the video, I think, for everyone. Yeah, as Patrick was saying, it was a very challenging project. And as both Sarah and Alan have touched on earlier, one of the main things is existing, perimeter wall and air tightness. And all these risks that we've listed out here of medium, low or high risk is something that we've learned going through the journey on this project. And I think it probably applies to all existing buildings where ENERFIT applies in any case. The design continuity of ENERFIT treatment is fundamental, which is the middle one there, to carry on that design brief going through where there is no novation. We had a very good team with the existing original architects that worked through with us, with the project team, with Patrick, to understand and engage with all the elements needed to achieve what we achieved, because at the time it was unknown whether it would be achieved, and it thankfully it was successfully. A lot of the things are normal in Passivhaus, others were not, particularly in an older building. We discovered a lot of items in the building that it gradually gave up, that we had to deal with as a team, and our subcontractor supply chain brought everything to the table, open and collaborative, and found ways round these surprises. Next slide, please, Lee. So this is this part of a published case study, normalised outturn costs, which established that it's not any more expensive to do Passivhaus, ENERFIT. There's some costs there that were unusual in this period. We had COVID, as we all know. We also had Brexit. availability of materials and so forth. But if you normalise it as this goes through, it is within the normal range of commercial refurbishment works, depending on the scope. Obviously, there's certain items in this particular building, and it was very unique, that made it very different. Open ceilings, exposed MEP and so forth, which is good for quality but unusual. Minimal areas where there's floor coverings, which again is not normal. And this was part of engagement with the end user and understanding what it was going to be like. Next slide, please, Lynn. So with these elements, these were quite specific with fabric enhancement to the building, blower-proof, procurement, diaphanite, wrap therm insulation and Gutex, and timber partitions rather than metal. So all those first 6 items, we engaged with one of our subcontractors. So they was in control of all those elements, which meant that the risk of install between different subcontractors was minimised. And if there was solutions to be made on overlap of different elements, that was worked through at workshops with the architect and the consultants to make sure that at each stage we qualified it, we tested it, we signed it off, and gradually worked through those design elements, as well as the triple glazed windows, which in effect was a wall inside the building, a timber wall envelope inside the existing envelope, which is a simple way of explaining what we did. And then new windows were put into the new wall, if you like, in line with the old window aperture. So basically, you put an envelope within the building, as we all know. Next slide, please, Lynn. A lot of the success of the quality at that building was because of what we normally do. Companies like ourselves, ISG, and other big main contractors, we do have a rigorous supply chain pre-qualification. But also in this particular case, we needed to make sure that the chosen subcontractors for different elements totally understood and had the passion that we all did about the quality to be maintained at every stage, because this was all new to all of us, really, certain elements, so we'll have to learn together. They had proven workmanship and they'd worked on other Passivhaus and high quality buildings before for us. We knew them individually, we knew the management structure. And we also had internal ENIFIT champions that would specifically just be keeping the quality of those elements as it went along. Every stage of the walls and so forth was checked, signed off, and made sure that if there was any discussions after installation, that was discussed and agreed and designed out at each stage. And again, the unique specialists for blower-proof, diaphanite and sonospray was again engaged by the subcontractors. They had total control of that. And it wasn't a main contractor individually trying to put those together. And it seemed to work really well. Collaboration was the key with everyone. Project team, Patrick, 3PM, us, architect, client, end user, and everyone having a proactive approach to resolution as the design challenges came up with some of the things that the building gave up to us. It was indicative of what we all learned and the way we got on with the challenges of the project. Next slide, please, Lynn. So this is fundamentally percentages of total cost of the elements. And the simplest way to look at this is, as was touched on before by Alan, I think, was the more that's put into the fabric of the building, the airtightness and the insulation, the less MEP, or it can be simplified, and the less need for heating and ventilation. We did have open windows, and that's part of the end user experience that we needed to make sure that they was aware of certain ventilation. There was a need to open windows and so forth, and it was a learning process for everyone. And again, it's taking everyone's view on board and educating everyone and learning along the way. These do not include client on costs. That was dealt with obviously separately to the main contractor, but I know Patrick's going to touch on those shortly and briefly. I think that's pretty much.
Yeah, next slide, please.
Next slide, please, for Patrick.
Yeah, thank you, Mark. I like all construction projects, I think just to feed on from Mark, they don't go without their stresses and their challenges. This was a complex project by any means. A lot of the issues Mark and his team were found out late and therefore had to be dealt with quite quickly, and it came down to the collaborative working, which is how the team got through this challenge. Set out here just how our contingency was ultimately spent. The final account position on the left is where that allocation ended up. Once we have normalized it onto the column on the right by taking out client change and warrant uplifts, which is effectively a budgetary uplifts for additional works. Once those were taken out, the contingency we'd allocated is where we ended up by spending. So next slide, please. Also, given that we were trying to deliver this through the pandemic and through post-Brexit, projects are not always on programme. One of those elements, if you achieve the quality, one of the elements of time or cost is going to slip. Programme here, you can see the programme was extended. We've split out here where those allocations sat. So a fair bit in relation to risks that the client was accepting from the point that we agreed the contract. There was an additional upfront COVID allowance when to take account of that. We did experience more asbestos than was understood to be there at the beginning. No real surprise really, but dealt with that contingency. There were significantly more building defects than we were expecting, and then we had obviously the usual client change as we were progressing. On Mark's side, the challenges he had to deal with were obviously any extension to that original COVID allowance. That was a risk that ISG signed up to at the beginning. Material delays principally given down to the challenges of Brexit and deliveries within a COVID world. So being able to split it between the two is probably almost impossible, but that's where the challenges really sat. And then lastly, and probably quite importantly in our industry, unfortunately, we had 2 subcontractor insolvencies. Just to make it worse, that was within the M&E teams towards the end of the project. And I must state through the insolvencies were not due to anything in terms of payment delays on this project. But as you can imagine, losing your main M&E contractor 8 weeks prior to completion causes a lot of issues for all teams. Next slide, please. Just to summarise, I'm not going to go through this in detail, but for those of you who are far more technically competent than Mark and I, you can see the benefits. I think that the message I'd like to leave you all with is that Passivhaus can be delivered at a similar or equivalent cost. It should not be seen as a premium uplift, and the benefits are significant. Thank you all.
Thank you.
Thank you, Patrick and Mark. I think for me, one of the important takeaways from your presentation is the fact that, particularly for the social housing providers, that not every property will be new build, and therefore NFIT has a significant part to play. And equally, a lot of the lessons learnt that you'd experienced as well cut across both public, private, and commercial sectors. So yeah, thank you for that insight. we've gathered a bit of time, which is great. That will give us a bit more time to go through all of the questions that we've got and those that are uplisted. So please keep up voting questions that you would like to see answered first. So last but by no means least, we've now got Phil Lewis from Randall Simmons, who's going to give us a QS perspective on costs. So thank you, Phil, over to you.
Thank you very much. Good afternoon. Last one on. I wanted to give a bit of perspective on from a QS point of view. We're Randall Simmons, we're QSs in the southwest of England. We do quite a lot of work on passive house schemes. In particular, we've delivered a range of schemes at scale, and I think that's the key for us. So we've delivered estate housing, we've delivered apartment blocks, commercial buildings. There is a range of buildings that can be, all buildings can be delivered passive house, and more that is occurring. We've got quite a number of schemes in progress at the moment, whether we're working them up like another leisure centre here, or schemes that are actually on site at the moment. So we've got a fairly good view on where we think costs are, and how to deliver passive house schemes. Really, it's about delivering at scale for us, and whether it's estate housing or multi-storey apartment blocks, or it's commercial buildings, they can be delivered at scale, but you just have to have a certain mindset to do so, I believe. And I think that mindset's got to be right the way through the whole team, about how to make it as commercial as possible, because we've all of us have got to prove viability for our schemes, or we don't build. And so it's for me, that commercial consideration needs to be very early in discussions, and before we really start design, we need to understand what we're doing, how we're going to do it, and how we're going to make it as commercial as possible. So that needs to include all those abnormal constraints that you need to for any project in terms of grounds and drainage and highways. And yes, we need to do the form factors and all the items that we've discussed as passive house, but not at the detriment of all the items that make the scheme expensive. So that's where that thinking has got to start. And I think the main message I want to get across to everybody is cost is the cost, actually, but the main item that's going to be that we can influence is risk, and risk is really important from a contractor's viewpoint. And if we can't manage that risk, then that's going to affect viability and our ability to obtain contractors to deliver our schemes. So I think I'll quickly go on from this slide, because I think we'll probably all understand what those additional costs are in terms of scope item. There is more scope in a passive house scheme, because we're building a better quality product that's not going to have a performance gap. So yes, of course, there is things that wouldn't be included in a building regs scheme. But for me, the biggest cost item, the biggest influence that we can do when building at scale is dealing with risk, and how contractors perceive the risk as much as anything else. I think perceived risk is for us at this relatively early journey of passive house as a main at scale build is so important. And we've had schemes where we've built, for instance, the large leisure centre in Exeter. We had to educate our contractors on what those risks really were and not what they thought they were, because that I think is key and fundamental. Otherwise, your risk pot in any tender is going to be large. So how we understand risk is absolutely key. And our designs need some elements of flexibility in order to assist that. So if there is just one product that will deliver, and there is no way of adding competition into that product selection, you're going to pay extra for it, because there's a risk that price will rise or it won't be available, etc. So we need to think about in our designs, how do we increase that flexibility in order to deliver the most commercial product we can that achieves Passivhaus. Okay, and there are other costs as well that we need that don't help us when designing the leanest building. Local authority planning requirements may be slightly at odds with what's best to achieve our most efficient Passivhaus design. There are lots of items in building regs that we need to sign off that probably aren't necessary in a Passivhaus scheme, but we still have to add those items in. So we just need to be aware of what they are and what the best way to reduce those cost factors are. Okay, and remembering on this slide that it's not just main contractors, it's a whole supply chain. And if you're building a large project, you would pay to invest in actually educating the supply chain that's likely to levy your scheme, because what you're actually adding with risk is subcontractor risk, and then your supply chain partner will add risk to that, then your main contractor will add risk to that, and it increases. So if you're doing a large scale scheme, you need to control those risk additions. Okay. Key cost factors. So a few things that I'm sure that we've seen when building, particularly with residential apartments, but also with commercial schemes, is for us at the moment, cladding is expensive and a disrupted market because of fire safety, etc. That may settle down, but it's becoming cladding is an element that we all need to focus on early doors in order to make it as commercially lean as possible. Tolerances and fixing systems need to be considered pretty early. How the QA of the installation is performed needs to be included in cost planning. And the biggest thing that sort of upsets me, if you like, is my most efficient build-up might not be the planner's favourite. Just be mindful also that monolithic construction will not achieve LABC or NHBC warranties currently. That might change. I know LABC are talking to manufacturers at the moment, but that's something for the future. But at the moment, we need to consider those warranty provisions for our clients when making sure that designs are progressing. Okay, so what is the cost of Passivhaus compared to a dwelling? I think we've seen from Sarah's presentation and the other presentations that the gap is reducing, and this is something we did a little while ago, just comparing 2022 and 2023. So 2023 was we saw units being built with the 2021 building regulations, and you'll see that for estate housing, the gap is closing, and the same for apartment builds. That doesn't mean to say that builds are getting cheaper. It's just that the base standard, the building reg, is coming up to closer to the delivery level of the passive house unit. These are based, and just as a word of warning on costs, these are based on substance super prices, don't include enabling works and site externals and all the additional prelims. We often forget that these add a significant cost to our delivery, and it's often the cost of all the other elements that will make a scheme viable or not. Okay, just a quick case study, a few schemes that we've delivered and our thoughts on how you can make them as commercially astute as possible. So this is a scheme which is on site at the moment. That aerial photo, I think, was last month. We're building 92 units in Exeter with this area at the moment under construction. We are building a poriform on this occasion. It's a phased construction in 3 phases, possibly 2. The big takeaway from this scheme is this is a big scheme. How are we going to control risk on it? Couldn't agree that the value of the risk pot with the contractor in open tender. So we actually changed our methodology of procurement methodology, and we went for a JCT constructing excellence contract. Now, this form of contract has a target cost and a guaranteed maximum cost, and we allocated risks to who they were most appropriate. We got all the risks out front. We had lots of discussions with our contractors, and we tendered and on the basis of where they came back and told us their risks and their pain and gain shares, kept it in competition. And one of the big issues when trying to deliver is keeping schemes in competition as long as possible. We were able, therefore, to include the risk register as part of competitive tendering, and we've agreed the allocation of risks, and that means the contractor is much more comfortable in delivering the scheme, because they've had to look at the risks up front and discuss with us what those risks were, but also we've allocated those risks to the right people, and we've discussed mitigation much earlier in the process and much more openly. So that's a change. That's a procurement change in order to get to a place where we could contract. Okay, I think that's a reasonable outcome. As we deliver more and more units, I don't think that will be necessary. But whilst Passive House is still a relatively small percentage of the overall build, then we need to consider more innovative methods of delivery. Next case study is estate housing. This was actually delivered in 2019, I believe. Primrose Park in Plymouth, 72 units. At the time, it was probably the largest scheme, the Passive House scheme, housing scheme in the country. Again, the big issue on this site was not Passive House. The big issue on this site was the great big sewer that had to be diverted and running across the scheme, and the sloping site. Passive House was a challenge, but it was by no means the biggest risk or the biggest cost issue. I think the key message, and again it comes back to Sarah's presentation at the beginning, was keep it simple. These are terrace units, therefore, the party walls are effectively insulated by the building next door. These are block-on flat with insulation and a render. Okay, they are very simple units. They passed their air test reasonably easily, that's such a thing, and they delivered a high number of units on a sort of compact site. Okay, so again, the message is it's all deliverable. You just need to think about it, keep it simple, and actually your biggest issue is probably not going to be Passive House. I've included this one. This is on the drawing board, but I just wanted to show you a nice, interesting shape as much as anything else, and just to prove that actually anything can be built to passive house, whether it's apartments, commercial, or other units. It just needs a strategy to do it, and a willingness to try and keep a commercial aspect of it as you go through the build. So this one, I don't think there's a huge uplift at all at 2,400 for a concrete frame and for a panelized system to deliver a large scale building. There are some challenges, and some challenges that we've sort of come against. Cost of insulation has been rising significantly for some time. We are building certain units without any insulation using poroformed block and a monolithic construction, but they need, we'll go back to the point about at the moment you can't get a warranty cover for those items. Balcony provision is complicated. It needs early structural engineer review. You don't want to create thermal bridging. It's not always possible to have balconies that are self-supporting, and even you sometimes get it is a high steel cost. So you just need to think about those design provisions as you're progressing. And then other items, I think really around limited supply chain at the moment. I did see sort of discussions about M&E kit. I don't think the M&E kit properly reflects our need for a passive house unit at the moment, because they're either too big or they're not big enough. We're seeing actually a move to heat pumps located within cylinders, and we're using those more and more. And I think the market for M&E goods is going to need to change to meet our changing heating and hot water demands. But at the moment, I think we're slightly over providing. Another note on future. So I'm not absolutely 100% convinced it's going to be 2025. So in England and Wales, we've got the Future Home Standard. If you look at what it's going to provide, or we hope is going to provide, then actually it looks pretty similar to what we're going to be delivering with Passive House. Okay, it's not quite there, but what it means is the gap between building a Future Home Standard house under the building regs and a passive house will be even lower than the 2021 building regs. So that gap is reducing. More to follow on whether the Future Home Standard will be there. I'm pretty sure it will be, but let's hope it will. And then a quick note on whole life costs. So I was going to put some data in, but I think really it's about the key messages. It's the higher your base energy cost, the bigger the saving from using Passive House on your life cycle costs are going to be. You're replacing a window under building regs and under Passive House is not going to be greatly different in your life cycle calculation, but your energy costs are, and I think again the slides earlier have shown that it makes a huge difference by reducing your energy costs. And I am aware that most landlords don't get that cost benefit. Residents do. But I still think it doesn't change the fact that actually your benefit is there in terms of affordability for your residents, for instance. It does reduce the cost for unplanned maintenance because this is a quality standard, not just a low energy standard. And I think that's really important and gets forgotten. And what that does, it's all those costs of not very good workmanship shouldn't be there if we've got a better QA system. Okay. And the capital cost increase in year one for a passive house unit spread over 25 years is actually quite minimal. I might dispute that. So key messages for me is if you're a QS, if you're looking at the cost, use the PHPP, okay, to understand cost implications. Some are very protective of their PHPP, which is great, but we need to do some modeling. We need to change a few things and see what works and what gives a bit better understanding. So my sort of hope in any project is use that PHPP to be as commercial as possible, as well as provide a good design. You're building better quality, so of course there's a premium, but that premium the gap is going to be reducing. And why should we be building to this quality anyway? My view is performance gap, which is a huge problem in UK construction, is a failure. If it doesn't do, if the building doesn't do what it was designed to do, then you haven't passed. Is simple look at it. And ultimately, it's all about risk and mitigating for all parties, and educating and making sure our tender lists that people understand those risks, and that our designers are mitigating the risks from as early as possible. Okay. Any other questions? Shall I hand back to you, Paul?
Yes, thank you, Alan. Great. I think as you've worked bang on time, which is superb, thank you for that. I suppose my key thing there, and I suppose it's obvious really, but you've very clearly said that if we prioritize risk management just as much as we do direct costs, then all those uncontrolled risks, which entail increased costs, have a lesser chance of being evident when you actually build out. And I think it's probably too easy. And the other point you make about passive house standard, particularly ensuring high levels of quality, which therefore mean less uncontrolled costs. It's obvious really, but thank you for that, because that's it's always good to see a different perspective, and that QS perspective is clearly another lens we should be looking at a lot more critically. Okay, so thank you to all the speakers. I'm going to deviate slightly from the running order. We were going to have a session 2 Q&A, but we didn't have a first one, so I'm just going to launch straight into Q&As. But before I do, I'd like, and just to give all the speakers a little bit of a quick moment just to gather themselves, is to have a second quick poll, because it always helps us with so many of you. We peaked at 384 people, according to my log today, which is a phenomenal number to get online. So it really demonstrates the demand for more knowledge and more understanding in this space. But yeah, Lynn, if I could ask you to launch the next one, please, and give the current 333 participants some time just to. One of the reasons we've asked this question is we obviously appreciate that there is a diverse range of knowledge, experience in this space. Some people just starting out, and that's great, and others that are more advanced, and we want to try and help both ends of that lens, or that telescope, should I say. So that just gives us a little bit of an understanding, reasonably fairly even splits there, which is great. Just wait for everybody to vote that wants to, and then we shall move on to the questions. So while we're just waiting for the last people to vote, could I ask all the speakers to turn on cameras and mics? And I shall attempt to navigate all of the questions and what's been upvoted.
I think my camera's given up, Paul. So,
Don't worry, we can hear
I think
you.
mine has, Paul, as well.
So let me just have a quick look in all of the questions. So interesting, we've had the ones that have been upvoted the most have caused quite a lot of chatter, which is great. And I think the very top one is probably less of a question and more of a statement. So I won't pose that, because I think the other delegates that have chipped in have catered for that one very well. And again, a few others here where people have kindly added in. Let me pick up one of the questions, not the most upvoted. So I'm going to put the question out if anybody has an idea. Unfortunately, apologies everybody, Sarah had to leave earlier than the finishing time today. But a question from Anna about additional costs quoted between Phil and I think it was Sarah mentioned 4%. I think it's probably very much project specific, but does anybody want to offer any further insight on why some people find slightly more or higher costs than others? And I appreciate that some of the presenters have said that actually there's probably not any difference at all in some instances. But does anybody want to delve a bit deeper? Yes, please.
I think that there's not much data. There's not a huge amount of data. I don't think you can say there are benchmarks, for instance. I don't think we've got enough data to have a proper quotable benchmark for cost planning. But we do have a number of schemes where we have some analysis done, and schemes, you know, there's such a variety of schemes at the moment. I find it quite sort of, you can give a broad brush, but I don't. But I think that the way forward is to consider your project individually before sort of saying, well, it's going to be this or it's going to be that, because there are so many factors involved that reflect on cost at the moment. And I think that's so. When we do cost planning for passive house schemes, we'll do fairly detailed cost plans and based on an assumed specification, which we'll run through with the team very early, because I don't think you can just necessarily use a rate off the top of a report. It probably is right. You know, of the schemes done, but there's not enough schemes at the moment.
I'd agree with that, Phil. Certainly from what I'm seeing on most of our schemes is exactly that, where you get into the detail of knowing why your scheme is different and actually price it out. The differences are far less than if you, I quoted the sort of 25% premium that is a sort of almost a default uplift, because we don't know we'll add a premium. But every time I've challenged that and analysed that on projects, we've got down way lower. I won't say every scheme is comparable, but it's a very marginal cost difference.
Thank you. Again, very helpfully, half of the questions that originally asked have been answered by written response from the panelists. So appreciate that. Thank you very much. Some of the hot ones that I thought they have now been catered for. So please have a look at those answered if you want. Interesting one here, and it was picked up in a couple of the presentations. Simon asked about, has the monetary value for calculating the benefit from higher quality, better performance associated with Passive House for the individual living there, not just the energy savings? And I think it's touched upon in a couple of the presentations that it's not all about the energy costs. There are a load of other financial benefits, both during occupancy as well. So I don't know if there's anybody wants to sort of touch on that. I suspect there's no calculator for that. It's very much a.
I'd agree, Paul. I think that there's a scheme, a new build passive house scheme I did for University of East Anglia Enterprise Centre 5-6 years ago. We have done POE for 4 out of those 6 years. So then the data is there. I can't remember off the top of my head what it says, but it's certainly worth. I would suggest people go and have a look at that. You'll get cost in use.
Brilliant. Anybody else on that side from their experience of properties, and or although if there might have been, you know, perceived high costs at the outset, but then sort of catered for or displaced by other cost savings down the line. Has anybody else had any experience, anything like that? Well, I'll just have a quick look at the other questions.
There was a question there about if we don't have benchmarks, how do we get an accurate cost for our building? I think that my view is very much to return to first principles, and you break it down and do an elemental process as instead of you just using a benchmark. You have to go much more detail earlier.
Thank you, Phil. I'm just going to put this is really I think with the large group of people we've got, a lot of these questions have been tackled by multiple people with lots of experience to draw upon, which is absolutely great. And I'm just trying to see which one might has not been tackled at all. So bear with me. There's a little bit about, you mentioned, I think, Phil, monolithic wall constructions unacceptable to LHBC. So somebody's picked up that one there to do with third-party accreditation. So I think that probably answers that one. Let's have a look. Somebody asked about the sort of cost comparisons for are those cost comparisons for outside London? Curious to know how city provision would impact costs, and I guess that applies to not just London but other large major cities, Birmingham, Manchester, probably as an example. Any thoughts from the presenters on that side of things?
Mine were southwest costs, but I think the gap is probably similar across the regions. I think, and I wouldn't say it's a, you know, these are what we're finding in terms of our gap, but there's an awful lot more construction within the non-passive house element than there is in the passive house element. So it's not that fully comparable data, but it's the best data we've got at the moment. But yes, it was ours was southwest.
I'm going to move to the chat now, because I think most of the questions, some are answered and some are still as open, but there's a lot of comments from both presenters and other delegates here. So I'm just going to move. Question from Martina here. Do the panelists, or could the panelists, I think it should say, could they comment on air source heat pump costs, uplift and payback period, considering that sometimes air source heat pumps installation is not justified given the reduced energy demand of passive house to achieve? Quite a long question. Does anybody want to offer a view on that?
I'm not sure, but I would say I think there is a need for smaller units, and that will derive bigger benefit because they should cost less.
Absolutely. And I think there's quite a lot from my experience of in this space of a lot of smaller and certainly much cheaper units, but not lower quality ones, about to enter the market. I know I won't name names, but there are quite a few companies that are bringing those out, which should transform it, and that will, even though that would transform the mainstream market, that will have a benefit to passive house, because they'll be, one, a lot cheaper, and two, scalable down, much smaller units. And anecdotally, somebody who's been working as a passive house consultant for at least 15 years built his own property, and he couldn't get an air source heat pump small enough for even though it was a big 4-bedroom house, and he had to write a disclaimer to his heating engineer that the one that they wanted to put in, he didn't want. He wanted one half the size, and he had to do a disclaimer that if it underperformed, and it hasn't underperformed. So I think there's a very good point there. Right, let's have a look at which questions haven't had any responses to from anybody.
Might be worth adding there was a question in the Q&A about flats.
Okay.
And with regards to flats, because the heat loss areas are much smaller, often there's no need to really go for anything other than direct electric panel radiators, because they're not needed very much. The heat losses are so low. It's when you get into houses, even terraced houses, where you have to start considering heat pumps, because there is that, that slightly higher heat loss. That's for Passivhaus certification standards.
Yeah, thank you for that, Alan, helping me out while I'm trying to navigate the chat and the quick Q&A. One question here which hasn't had a response, might be quite an easy one. Has anybody found the use of MVHR does not work as design end because the occupier opens windows and doors for fresh air and does not use the building as intended? So that's quite a simple one.
Yeah, I think certainly on all of our schemes, end user training is quite fundamental. Most of my schemes have been commercial, and therefore you've got differing tenants who all need to be trained and understand the systems they're working.
And I think our next session that one of the speakers kindly mentioned on the 29th of November to do with handover maintenance, we'll address some of those issues. So just looking in the chat, there's a couple of questions here. One from Adam, I haven't got a second name, so I'm not sure. How did the EO change from 55% in 2015 to 8% in 2018 and then 4%? Was this due to alternative materials? I'm not sure who's best to answer that. And Adam, if you did want to turn your mic on and just say who you were sort of directing that was presumably off somebody's slides. Or put a note in the chat if you want me to direct it to a specific person, that would be helpful. Let's have a look. So lots of statements. Yeah, I think this was sort of picked up. Are the Passivhaus costs really reducing, or is the gap decreasing because of building regs, etc., increasing base costs in recent years? And I think another dimension on that was just picked up in Phil's comment about, as we narrow the gap between what is required as a standard and Passivhaus, then the costs are going to go up associated with making these better performing buildings. But I think that's quite a useful comment to make, really. Has anybody got any views on that they'd like to?
At risk of answering the previous question there about how costs have reduced so rapidly, I think there's a couple of things there. Firstly, there's the kind of grand designs effect, where a lot of early Passivhaus certified buildings were kind of self-builds and one-offs rather than kind of schemes at any kind of scale. I think there's a lot of costs that often sort of creep into schemes like that, where there aren't actually Passivhaus costs. They're kind of self-builder costs. They want the sort of luxury kitchens and that kind of thing. So it's quite easy to conflate the two. So that might partly explain that. As we start to build, more standard housing, that would partly explain it. And also first-time costs. I think there's definitely things like Passivhaus tradesperson training. Also things like potentially reworking if things are done wrong, say air tightness, that kind of thing. With very early schemes when there wasn't much experience around, potentially, it does cost a bit more to do things. But then if you do it again, then the costs will naturally reduce. There's that sort of first-time premium, I suppose you could call it, and that very rapidly disappears once anybody, really, whether it be the architect, the client, the contractor, once anybody who's involved has done it more than once. It gets much cheaper rapidly. The worst thing with anything really is someone to say, okay, we tried to innovate and it cost money, so we're never doing it again. But well, no, you need to learn the lessons and go again. There's plenty of case studies around pilots. I'm actually doing quite a lot of work at the moment on the earliest passive houses in the UK, so from sort of 2007, 2008. So we're actually starting to learn the lessons on buildings that are kind of out of their structural warranties, that sort of thing, be able to compare them with standard builds. So yeah, I think there's several things that go into it, but yeah, it's not just the fact that it's easier to buy MVHR units now, although it is, that's part of it. Yeah, there's a few different things come into it there.
Yeah, thank you very much, Alan. Somebody did kindly try to help me out with the EO reducing costs one. I think it came from one of Sarah's slides. Now, those are the 2018 cost benefits, and as Sarah mentioned in her presentation, the plan is that from that paper, I think it was officially published in 2019, the plan is to do a revised update on that paper next calendar year, hence the need for the working group that she mentioned. So I think a few of you have already said you've got some experiences and costs that you're happy to share. And then Kate has also think there's a lot came from early passive house inexperience, which I think has just been borne out by what Alan's perhaps mentioned there. So let me have a look.
Well, there's a couple of questions about sort of why are my values and Sarah's values different? They're probably not. I think so. We're quoting 10-15% of substructure and superstructure price only, not the total cost of the scheme. So when you take it over the total cost, which is a bigger number, there'll be a lower percentage. But we're probably not comparing apples with apples by comparing those two slide packs.
Brilliant. That's really helpful, Phil. Thank you. There's one question here in the Q&A, and as this is predominantly focused, or primarily focused, should I say, on the social housing sides, question about what funding options for delivering passive house in existing properties for housing associations. Funding is a big issue, and often significant additional spend is required on top of existing works programs. And there's been a helpful comment there. So we do know that budgets are tight in any place, and I think one of the things that we are doing is working more closely with a lot of social housing providers through this series, and looking at those 4 different perspectives: the cost and the handover and the procurement side of things in previous ones. So the idea is that we'll be pulling all of that learning together, and we have a plan for next calendar year to start to replay back to all of the people that have attended all 4 of the sessions, including the one we're going to have in November, and some of the deeper dive with the working groups on a few of the topics. So what we hope to do is then provide a set of guides and some further learning that we can then share through maybe a wrap-up session, and of course then things like our annual Passive House conference that we have.
Specifically in terms of retrofit funding, there's things such as the Social Housing Decarbonisation Fund in England and the Optimised Retrofit funding in Wales, which require PAS 2035 compliance in order as a sort of prerequisite of funding, or as a requirement of funding. So it's not explicitly passive house, but really what PAS 2035 is getting at is a sort of bureaucratic process that's been put in place to ensure that insulation is continuous, that you're not getting thermal bridging at sort of the eaves around the windows. And actually it's not aiming for NFIT standards. It's not called passive house, but it's the same building physics, continuity of insulation and continuity of air tightness. That's being reviewed at the moment. So I think I'm hearing that air tightness may be kind of becoming a larger part of it. So yeah, it's the same thing. It's building physics. It might be called passive house, but it's the same things we're talking about. And when you're increasing the insulation of the building, then you have to start thinking about the ventilation, and then you start thinking about heat recovery, because what's the point in having lots of insulation and then having to ventilate it, and then actually introducing air into the building via trickle vents in your very high performing windows. You're sort of bypassing the insulation layer. So that's when you start down the thought process of heat recovery to ventilation, which is not easy to get into existing buildings. Definitely not difficult in practice, but in terms of the actual approach, it all leads to the same places really, which is, you know, air tightness, continuous insulation, and you've got to consider your ventilation. So in some ways, the funding for retrofit is already linked to those kind of principles. So it's just under a different kind of banner, really.
Yeah, thank you, Alan. And actually that relates to what the latest question we received from Kevin about several questions that have already been posted all over the place to do with trades and training. And he sort of summarized it by saying, interested in hearing from the panelists on the current state and current movement in trades training. Following from this, there's been much of an upset caused by retiring baby boomers during COVID. And Kate has responded, mentioning co-action there. And certainly at Passivhaus Trust, we've been looking at with a range of different existing and new potential partners up and down the UK, looking at that. And I know you just mentioned PAS 2035, Alan, and certainly for the non-passive house retrofits, that's sort of the standard which most should be adopting, certainly, or the quality assurance side of it. But we've been looking at how we can sort of bridge between sort of traditional retrofits and the NFIT standard, and how we can work with the likes of Coaction and Best and Enmite and other traditional providers. And there's quite a lot at the moment coming out of DESNES, so the government department, and their 5 net zero hubs that cover England. And there's a lot of funding for home decarbonisation skills training. So there's something that we're working with partners and other similar organisations and training providers from all sectors to look at how we might increase those that level of training awareness. And as Alan points out, to do with things like air tightness, you know, and where an unusual detailing which need retrofitting. So there's a whole scope of new awareness and therefore new quality assurance that's needed when we do these deeper retrofits. But yeah, that's a very topical question as well.
Yes, I've got meetings on that next week. Exactly all that stuff about the trades training and stuff, and trying to take that forward. Just on the retiring baby boomers. Yes, I think that's an issue more generally across the sector, but specifically in terms of the sort of concept we're talking about here, probably not so much, because they actually have to sort of unlearn the way they've always worked, and start thinking about things in a slightly different way. So in some ways, it can actually be easier just to start again with sort of new people. That's specifically to do with things like airtime. Obviously elsewhere, there's a general problem with lack of experienced tradespeople, supervisor level, that kind of thing.
Absolutely.
One other thing just on PAS, it's worth bearing in mind that PAS 2035 is a quality assurance process, really. It's not a standard, not an energy performance standard. So you sort of mentioned that, but I just wanted to kind of emphasize that, really. PAS is a very long sort of winded bureaucratic way of ensuring that quality is up, but it doesn't actually give you a sort of kilowatt hour per square metre per annum target or anything like that, which is, I think, one of its weaknesses, and another issue, really.
Yeah, and I think we've been looking at how, if it was to work more closely with PHPP, for example, as just one option for a better building physics approach to it, then there could be some sort of unintended consequences that are removed right from the word go.
Yes, I mean the PAS standard does mention PHPP. It's seen as it's recognised as a valid standard. It also recognises SAP as another supposedly building energy modelling method, but that's really asking more of SAP and EPCs than they were designed to do. It's kind of, they are, EPCs are for compliance, not design. So they're sort of perhaps asking them to do a little bit too much there. So I prefer PHPP, but
brilliant.
Yeah.
Okay, well, we've got 4 minutes to the end, and I think I'm going to call a halt there to my rather haphazard way of managing all these questions and comments that have been coming in. But thank you for all the speakers and the delegates for actually putting lots of comments and lots of responses and having sort of an online chat about that as well. So that's much appreciated. So if I could just have some of the closing slides now, Lynn, I shall wrap us up. So really, this is just really just to finish off this session and explain a little bit about our principal campaign. So as you know, this is the social housing campaign. Again, all of the links and that will go in your electronic party bag that you'll get. So that'll be coming forward. There's another campaign around passive house and planning, and obviously retrofit is another key element to that. So those are our principal 3 campaigns. Next slide, please. And again, some of these guides have been very comprehensively injected into the chat function. Thanks very much to Lynn from the Trust, who's organised everything. She's been dropping all these in at the right times to basically give people that greater depth of knowledge if they want it on each of these. So we've got obviously the social housing, how to build a passive house, and passive house benefits, amongst others. There'll be more links in that chat there. And now in October this year, we've got our Passive House conference in Edinburgh. I believe tickets are still available for that for anybody that wishing to attend. And then, as mentioned a couple of times, we've got our 29th of November final of the 4 this year, handover maintenance and passive house living. Interestingly, our hope is to get somebody that I did mention, but I didn't say his name, who'd been doing a lot of work and has got sort of some quite detailed analysis 10 years on for a particular project. So that will be quite useful, and some user perspectives in there as well. Just working that one up now. This one's finished. I shall be looking into that one in greater detail. And of course, our winter edition of the Passive House Open Days. Again, link there, 23rd of November. There's a bit of a clue there in the bit.ly link. Okay, so I think that is everything. And once again, thank you for our diverse and very expert speakers who've really given us many different perspectives on the same multi-dimensional cost issue. I know it's a very, very emotive subject and very complex, and we can't just see it through even 3-dimensional. I think on this one, I think there's a 4th dimension to it somewhere. But thanks very much to everyone, and hopefully see you on the 29th.
Thanks, Paul.
Thank you. Just